Hey, Wagwan, it's Mr. Garfield here, and we're going to be looking at a CAPE integrated mathematics question from Module 1, that's Foundations of Mathematics, and I'm focusing on how to factorize a third degree polynomial. All right, so here it says given that g of x equals 2x cubed plus 7x squared plus x minus 10, and we are to factorize g of x completely. Okay, so this is what we call a third degree polynomial. All right, we say it is third. We say that this polynomial is a third degree polynomial because the highest power of x is 3. Okay, good. Now, how do you factorize this polynomial? Well, in the exam, you might be given a factor. For example, they might tell you that x plus 1 is a factor, right? Or the polynomial is divisible by x plus 1, which simply means that x plus 1 is a factor, right? But what if you're not given any factors? Right? Because if they give you a factor, you can apply the factor theorem and actually factorize. But what if they don't give you any factors at all, like in this case, right? Well, what you will have to do is to use trial and error, all right? Meaning that you will have to find out the factors of this polynomial, okay? Let's write that down. So solution using trial and error. Okay, using trial and error. Okay, now how do you come up with the factors now for this polynomial? Well, what you will have to do, there are different ways of doing it, but I'm just going to show you one way, all right, one method. So look at the constant at the end there, all right? Look at the constant, that's 10, and we're going to be focusing on the factors of 10. All right, we're going to focus on the factors of 10. Now, of course, the factors of 10 are 1 itself, right? 1 and 10, 2 and 5. Okay, those are our factors. Great. Now, these are our factors of 10, okay? And you are going to substitute each of these values in for x into the polynomial. All right, so you're going to try x equals 1, x equals 10, x equals 2, x equals 5. Okay, I won't do all of them. I'm just going to tell you what the factor is. And also note that even though we plug in these values into the polynomial, also try the negative of it. All right, meaning that you can try plus or minus 1. So if positive 1 don't work, all right, then you try negative 1. So basically, the aim is that whenever we substitute the number into the polynomial here for x, we must get 0 as the output. All right, that means that we have a factor. Okay, so if you try positive 1 and you don't get 0, you can try negative 1. If you try positive 10 and it doesn't work, you can try negative 10. If you try positive 2 and it doesn't work, you can also try negative 2. All right. If you try positive 5 and it doesn't work, you can also try negative 5. Okay. So I'm just going to tell you I'm just going to show you what the factor is. Okay. So we're going to let x be equal to negative 2. All right. We're going to try x equals negative 2. And it told us that g of x equals 2x cubed. Let's write that down. We know that g of x is equal to 2x cubed, okay, plus 7x squared plus x minus 10. All right, good. And let's just try substituting x equals negative 2 and see if we get 0. Yes, let us try substituting x equals negative 2 and see if we get 0 as our output, okay? So we have g of negative 2 is going to be equal to 2 multiplied by negative 2 cubed plus 7 multiplied by negative 2 squared, okay? And then x here is going to be negative 2 minus 10, all right? That is what we have. Good. So I can say that g of negative 2 is equal to negative 2 cubed. That's going to give me a negative 8, and a negative 8 multiplied by the 2 will give me a negative 16, okay? Then I have negative 2 squared, which is 4, all right? 4 times 7, that's going to give me plus 28, okay? Minus 2 minus 10, all right? Now, if you put these values here, if you compute this into your calculator, all right, you will recognize that g of negative 2 is equal to 0. Okay, so negative 16 plus 28 minus 2 minus 10 is going to give you 0 as the output. And that is what we were looking for. Okay, that is what we're looking for. Now, it means that we have a factor, right? So since I'm just going to write a statement here, all right, your statements are very important in your examination. So since g of negative 2 is equal to 0, it means that x plus 2, all right, the expression x plus 2 is a factor of g of x. Okay? It means that x plus 2 is a factor of g of x. All right? So you might be wondering where I got this x plus 2 from. Okay? So let's just look at the equation here. All right, let's look at the equation here. If I carry the negative 2 to the left-hand side, right, by adding both sides of the equation by 2, I will get x plus 2 equals 0. All right, that's how I'm going to get the x equals negative 2 to substitute into the function g of x. All right, so it means that x plus 2 is a factor. Great. Now we know that x plus 2 is a factor. All right, the next step into actually factorizing this polynomial is to actually do division. All right, now there are different methods of division. Right, you can either do the polynomial long division or the synthetic division. All right, I believe I did the synthetic division recently in a logarithms video. I'm just going to do the polynomial long division. All right, so let us use polynomial long division. So using polynomial long division. All right, using polynomial long division. Great. So what I want to do now is to divide g of x by the factor x plus 2. All right. And since we know that x plus 2 is a factor of g of x, when we divide g of x by x plus 2, it means that our remainder must be equal to 0. Okay, good. That 0 that we got as the output is actually our remainder. Okay, so let's do our division here. All right, our division. So I'm going to have x plus 2 here, and I'm dividing that by 2. I'm dividing the g of x by x plus 2. All right, so that's 2x cubed plus 7x squared plus x minus 10. All right, I'm going to draw my line here. Excellent. Great. Let's just now do our division. All right, so what is our first step? Our first step is to divide the 2x cubed here. All right, we're going to divide that 2x cubed by the first term here, which is x. All right, so we're going to divide by x. All right, we're going to divide by x. Good. Now, you recognize that something can be canceled here, right? Or if you remember your laws of indices, we can say that in the denominator here, we have x to the power of 1, right? So if you recall your laws of indices, you know that you subtract the powers once you have the same base, We have the same basis here because we have x here and x here. So we can say that this is the same as 2 to the power of x, 2 times x, sorry, to the power of 3 minus 1. So you subtract these powers. So when you subtract the powers, you get 2, right? 3 minus 1 is 2. Good. So that 2x squared that I obtained there is going to be the first term here in my quotient, all right? So 2x squared, all right? Good. Now I'm going to take that 2x squared and multiply it by my divisor here, which is x plus 2, all right? So 2x squared multiplied by the x will give me a 2x cubed, and 2x squared multiplied by the 2 will give me a plus. 2 times 2 is 4, all right? And we have x squared. Great. The next step here is to subtract, all right? So we're going to subtract here. Great. Now 2x cubed minus 2x cubed will give me 0, okay? And 7x squared minus 4x squared will give me a positive 3x squared, right? Okay, give me a positive 3x squared, okay? And I'm just now going to carry down this x here, all right? If you remember your division from primary school, all right, that's the same division that we're doing, okay? So we have 3x squared plus x. Great. I didn't have to write this 0, by the way, but I just wanted to make it clear that when you subtract, you get 0 here. Okay? Good. So I have 3x squared plus x, and I'm going to do the same process again. All right? I'm going to divide that 3x squared. Okay? I'm going to divide that 3x squared there by the first term in my divisor, which is x. Okay? Good. So by subtracting the powers again from our laws of indices, this is going to be 3x, right? This is x to the power of 1. So you subtract the power. So this is equal to 3x to the power of 2 minus 1. And 2 minus 1 we know is 1 as the power. But you know that we don't really write the power 1, right? Good. So that is what we have. So that 3x there that I have obtained is going to be the second term in my quotient. So I have a positive 3x there. And just like with the 2x squared, I'm going to multiply this 3x by the divisor, each term in the divisor, right? So 3x squared multiplied by the x will give me a 3x squared, and 3x multiplied by the 2 will give me a positive 6x, right? And remember, our next step from here is to now subtract, all right? We're going to subtract. Great. Now, what can I do here now? 3x squared minus 3x squared is going to give me 0 here, okay? That's going to give me 0. And then I have 1x. This is actually a 1 in front of the x here, okay? So we have 1x minus 6x, all right? That is going to give me a negative 5x, okay? Good. And I'm just now going to carry down the negative 10 here, okay? So I'm going to carry down this negative 10. So we have a negative 10 here, all right? And doing the same process again, I'm going to divide the negative 5x by the first term in my divisor, which is x, okay? And clearly we can see that these two x's cancel out, which gives me a negative 5, right? So that negative 5 will be here in my quotient. And I'm going to multiply that negative 5 by the divisor, x plus 2. So negative 5 multiplied by x will give me a negative 5x. And negative 5 multiplied by 2 will give me a negative 10. All right? The next step from here is to now subtract. Okay? Now negative 5x minus a negative 5x, that's the same as negative 5x plus 5x. That's going to give me 0. And I have negative 10 minus a negative 10, which is the same as negative 10 plus negative 10, all right, which is also 0. So you see that my remainder here is 0, so I can't go any further, okay? So that's where my division stops. Okay, good. So now that we have done our division, what can we say now? Well, this is what we did. We divided 2x cubed plus 7x squared plus x minus 10, all right? I divided that polynomial there, which is g of x. I divided that by x plus 2, okay? And I can now say that this is the same as, so whenever you divide a polynomial by a term like this, x plus 2, all right? If you divide any two polynomials, really, it is going to be the same as the quotient that you have obtained, okay? The quotient that we obtained is 2x squared plus 3x minus 5, all right? That's our quotient. So whenever you divide two polynomials, it is going to be the same as the quotient that you have obtained, which is 2x squared plus 3x plus 5 in this case, okay? Plus your remainder, which we know is 0, all right? Plus your remainder divided by your divisor, which is x plus 2, okay? Good. Now, of course, 0 divided by x plus 2 is just 0, right? So we can write this as, we can just write this as 2x cubed plus 7x squared plus x minus 10 divided by x plus 2, all right, divided by x plus 2 is the same as 2x squared plus 3x plus 5, right? Because we know that 0 divided by x plus 2 is just going to give us 0. Great. Now, remember I told us that we need to factorize this here, this polynomial here in the numerator, right? So I'm gonna get rid of the x plus 2 here in the denominator by multiplying both sides of the equation, or both sides of the identity rather, by x plus 2. And if I do that now, I will get 2x cubed plus 7x squared plus x minus 10. And that is now the same as multiplying the right-hand side by x plus 2. I will get x plus 2 multiplied by my quotient, which is 2x squared plus 3x plus 5. Okay, good. So remember here on the left-hand side, this third-degree polynomial is just the same as g of x. All right, and we're saying that g of x is the same as x plus 2 multiplied by 2x squared plus 3x plus 5. Okay, good. Now, this is now factorized, right? This is now factorized, right? This is factorized, but what did the question say? The question said that we have to factorize completely, factorize g of x completely, right? So what you need to check is this. You need to check if the quotient here, which is the quadratic here, the 2x squared plus 2x plus 5, you need to also check if that polynomial or that quadratic can also be factorized, okay? So let us check if it can. So we're trying to factorize the quotient, right? Which is 2x squared plus 3x plus 5, okay? So if you remember how to factorize the quadratic, you need the product, all right? The product is gonna be your a multiplied by c, multiplying the two n numbers here. So you multiply the number in front of the x squared term, which is 2, all right? So 2 multiplied by the constant here, which is 5, okay? So yes, I think I made an error here. Right, this is supposed to be negative 5, right? We're supposed to have a negative 5 here. not positive 5. All right, let's just correct that. Negative 5, negative 5. Great. And let's correct it here also. So we have negative 5 here, negative 5 here, and also negative 5 here. Great. So it means that my product A times C is going to be 2 multiplied by negative 5. All right, which is going to give me a negative 10. And my sum is going to be the number in front of the x term, which is 3, which is my b term. Okay? So what this is saying is that I need two numbers. When I multiply them, I'm supposed to get negative 10. And when I add them, I get my sum, which is 3. Okay? And those two numbers are 5 and negative 2. All right? Because when we multiply 5 and negative 2, we get a negative 10, and 5 plus negative 2 is going to give me a 3. Okay? So I'm going to split the middle term here, 3x, using those two numbers. So I can say that this quadratic here is equal to 2x squared. I'm now going to split the 3x into the negative 2x and the positive 5x, okay, minus 5 at the end there, okay? And this is now going to be equal to, I'm now going to group these two terms. All right, let's look at these two terms and see what can be factored out. Well, you should recognize that 2 is a common factor, all right, and x is also a common factor, okay? So I can factor out a 2x there. And when I factor out a 2x, I will have x minus 1 remaining in brackets, right? Because 2x squared divided by 2x is x, and negative 2x divided by 2x is negative 1, okay? And if I look at these two terms here now, you recognize that 5 is common, right? 5 is common, so we can factor out a 5, all right? So we have plus 5, and in brackets I will have x minus 1 remaining, because 5x divided by the 5 will give me x, and negative 5 divided by this 5 will give me a negative 1. And that is what we have, okay? Now, if you look carefully, you recognize that x minus 1 is here, and x minus 1 is here. That should always happen whenever you're doing factorization by grouping, right? Meaning that you have 4 terms here, right? Here we have 4 terms, and we're factorizing by grouping, okay? So if you don't have the same thing inside of the brackets there, you know that you have done something wrong, all right? So you should remember that from C-set mathematics. So x minus 1 is now common, so I'm going to factor out x minus 1, and I'm going to write what is left on the outside, which is 2x plus 5. And that is the factored form of the quotient, okay? So I can now say that g of x is the same as x plus 2 multiplied by my quotient in its factored form, which is x minus 1 times 2x plus 5. All right? Now, how many factors do you recognize that we have here? We have 3 factors, right? Let's make a note of that. So note, we have 3 factors. All right? The 3 factors are x plus 2, x minus 1, and 2x plus 5. Right? And if you look at the polynomial that was given to us here, the highest degree was 3, right? That's why we call it a third degree polynomial, right? So since the highest degree in the polynomial is 3, right? It means that you are to obtain 3 factors, like what we got here, okay? 3 factors. Likewise, for the quadratic here, you recognize that the highest power of x is 2, and that is the reason why we obtained 2 factors here, which is x minus 1 and 2x plus 5. All right, good. Now, let me also just clear up that sometimes the quotient cannot be factorized. All right, if it can be factorized, then you leave it as it is. Okay, so that is the end of this video here. All right, we have just factorized a third degree polynomial. All right, so I hope that this video was helpful. If it was, please ensure to like up the video and subscribe to the channel. I am Mr. Garth Reed, student ambassador for the University of Technology, Jamaica, and I'm a mathematics teacher in training in the School of Mathematics and Statistics. I thank you for joining.